Hi, good evening, everyone. After a long time, so we are back with the chemistry chapters. Okay, very sorry those students, class 12 students, because I was really busy with class 10 mathematics. That's why I could not upload any videos for you guys. But fine, now we are going to start. Okay, the new chapter which we are going to start today is Unit 9, coordination compound. This chapter is very important for your examination, board examination point of view. It will gives you 3 to 4 marks. Okay, one question for 2 marks, one question for 1 mark, or one question for 3 or 1 mark, like that it will be coming in your board examinations. So dear students, this chapter it's very easy. Okay, the thing is that you need to concentrate properly. Okay, try to listen the explanations properly. If you are not understanding, rewind the video and watch again and again. Try to understand it. If you understand this chapter from the beginning, it is very easy, or else it will be little difficult for you in the middle if you don't understand from the beginning. Okay, so yeah, this is your channel Kumar sir. Okay, chemistry chapter 9 we are going to start for class 12. So okay, well, let's begin. Okay, so the name of the chapter here is coordination compound. So first of all, let us try to understand what is coordinations compound. So coordination compound, what does it means? What is the definitions? I want you to take down the notes also, because during the explanations I will be giving you explanation as well as the notes. So dear students, you don't need to go anywhere for the notes. Everything will be given you in this channel Kumar sir. Okay, so just subscribe it and visit it regularly so that you can get the notes and the explanations on time. Okay, so let's start. Coordinations compounds. So what is coordinations compounds? Those molecular compounds which are formed by the combination of two or more simple stable compounds. Those molecular compounds, okay, those small simple molecular compounds, when and they should be stable. Okay, those molecular compounds which are combining, they should be simple and stable. This point you should remember it, you should mention in your answer. Okay, those molecular compounds which are simple, stable, when they combine together. Okay, when they combine together and they are capable of retaining their identity. Remember, they are capable of retaining their identity before combining. Whatever their identity is, after combining also, if they retain it, okay, and retain their identity, okay, they are capable of retaining their identity in the solid as well as in the dissolved form, as well as in the dissolved state. Means when it is in the solid form, it will have some identity, and even if you add mix up with the water, still it will remain, it will retain the same identity. So that is the speciality of this coordination compound. So what is coordination compound? Coordination compounds are those molecular compounds which are formed by the combination of two simple, two or more simpler, okay, stable compound, two or more simpler stable compounds, and retain their identity in the solid as well as in the dissolved forms, are called as what? Coordinations compounds. For example, let us try to understand. This is one simple stable compound, that is nickel chloride, nickel dichlorides, okay, plus CNH3, okay, 6NH3, that is ammonia. Okay, so see here nickel chloride and ammonia, these two are simple and stable compounds. Okay or not? Got it? The stability, they have that stability. So when these two simple molecular compounds, when they combines together, they will be giving us what? A complex compounds. Okay, this is complex compounds, or we call it as what? Coordinations compounds. Okay or not? So these two simple molecular compounds, simple molecular compounds, when they combine, after combinations, whatever product they give us, okay, is called as what? Coordinations compound. So this is nothing but what? Coordinations compound. I hope you have understood what is the meaning of coordination compound and the definitions. Okay, now coming to next part. So there are two types, two coordinations compound and double salts. Okay, these two are almost similar, but still they have little so many differences. They vary in different respect. Okay, so let us now differentiate between double salt and coordinations compound. Okay, so on the left side, as you can see, we have written double salt, and on the right hand side we have written what? Coordinations compound. So double salt, first property is what? What is the first property of double salt? It exists only in the solid state. Means what? Double salt, it will exist only in the solid form. Okay, remember, it will exist only in the solid form, whereas coordinations compound, it will exist, what I told you, it will exist in solid as well as in the dissolved form when they are mixed with the water. When water is added to them, at that point of time also, it in that case also it exists. Okay, so double salt, it exists only in solid state, whereas coordinations compound, okay, it exists both in the solid as well as in the dissolved form. Okay, so this one you have to remember. Okay, this is the first point of difference. Very easy. So second point of difference is what? It loses its identity in the solutions. Okay, so this double salt, when you are dissolving it in the water, okay, in the solution form, when they come in the solid form, they will have their identity. Okay, but in the solutions, when they are dissolved, then they loses their identity. How it happens, we will be discussing in the later part of this chapter. Okay, now the second point on coordination compound is what? It does not completely lose its identity in the solutions. Of course, coordination compound also little bit effect will be there in their identities, but completely it will not lose away its identity as double salt has done. Okay, double salt, it will lose its identity completely in the solutions, whereas coordination compound, it will not lose its identity in the solution form. I think point number 2 is clear. Now let's go to the point number 3. Point number 3 says its properties are essentially the same as the constituent compounds. Okay, so as we have discussed, that double salt or coordination compound, both are formed by what? Both are formed by two simpler stable molecular compounds, right? Two simple molecular stable molecular compound, right? Two simple stable molecular compound, both are formed by that. Okay, but in case of double salt, what will happen when it will dissolve? Okay, when it will dissolve, it will show the same property as its characteristic, means like the one from which it is made up of. That one and the double salt both will show the same properties. For example, I will tell you, suppose this is one double salt, so it is formed from this constituent or not? These are the two constituents which we combine together to give a double salt. This is not a double salt, this is a coordination compound, but just I am giving you an example. Okay, so this is suppose double salt. This double salt is formed from which coordination compound? These two coordination compound. So this double salt and these individual constituent compounds will have the same characteristics, same properties. Understood? Okay. Whereas in case of coordination compound, it is not like that. The coordination compound which is formed, these coordination compound properties and constituents properties, it will be very much differing, it will be very much different. Okay, once again I'm telling you, the coordination compound which is formed by the two simple molecular compounds, these coordination compounds have properties, and this constituent, this separately their properties, it will be different in case of coordinations, but in case of double salt it will be same. Okay, fine. Now coming to the fourth points. Okay, examples. So double salt examples is what? More salt. There are many examples, but the very common one is more salt. You might have studied in class 11 also. Okay, salt analysis. So this more salts. Okay, more salt formula is what? FeSO4 NH4 2 times SO4 6H2O. This is the formula for molecular formula for more salt. Okay, so more salt, as we have discussed earlier, now this more salt when it is dissolved, Point number 3, remember, it has its properties are essentially the same as the constituent. So more so when it is dissolved, it will gives the it will dissolve and it will give the properties of what? Separate property will give. It will give the property of Ap2 positive, NH4 positive, SO4 negative. Means when this more salt is dissolved, it is in the dissolved form, then they are losing away its identity. Okay or not? They are now representing Ap, NH4, SO4. Means they are totally dissolved and they are totally separated into a constituent. Okay or not? But coming to the coordination compound, in case of coordination compounds, when they are dissolved, they do not show the properties of NiCl2 or NH3. When they will be dissolving, they will not be showing the property of NaCl2 or NH4, NH3. Okay, that is ammonia. That means this one, when it is dissolved, they are going to show the property of its characteristic constituent compound. Whereas these coordination compound, when they are dissolved, they are not showing the properties of their constituent compounds. I hope these 2 points are very much clear to you. Okay, now we shall proceed further in this chapter. Okay, everyone, now we are going to discuss some important terms used in the coordinations compounds. Okay, so there are some important terms which we are going to use in this coordination compounds. Okay, so one by one we are going to discuss it, and dear students, remember the definitions of all these are very important for 1 marks in your board examinations. So, and if you don't understand the definitions afterwards, when we go inside the chapters, it will be very difficult for you to understand the things. Okay, so that's why I will recommend all of you to listen properly. Okay, and try to understand it. Okay, the definitions you might be thinking that okay, I'll mark it up and done. No, you have to understand also. Understanding is also required. Marking up, of course, it is has to be done, but understanding is also required. So the first terms we are going to learn today is coordination entities. Okay, coordination entities or complex ions. Coordination entities or complex ions. Okay, so in this chapter, coordination compound, we are going to use this term. So what is the meaning of this term? We will try to understand now. So what are the definitions for it? It constitutes a central metal atom or ion bonded to a fixed number of oppositely charged ion or neutral molecules. Okay, so in simple I will tell you for example, you can see coordination entities. For in simple language I'm telling you definition, of course you will memorize it. Okay, it constitutes a central metal atom. So what is central metal atoms? That one also I will tell you. Okay, or ions bonded to a fixed number of oppositely charged ions or neutral molecules. Okay, so remember dear students, coordination entities is nothing but, in short, you can understand that here in coordination entities, always remember those compounds which will be given inside a square bracket. Okay, in short I'm telling you, this inside this bracket, square bracket, those compounds which will be given, we will call it as what? Coordination entities, or we call it as complex ions. As you can see here, this is an example of what? Coordination entities or complex ions. This is also an examples of coordinations entities or complex ions. Okay or not? To make it very simple, let us try to understand here. One example I have taken, NiNH3 6 times Cl2. Okay, so here you can see that, okay, this one, when it dissolves in the solutions forms, then you will find that this is called complex, okay, ions or complex coordination entities. This is called as a coordination entities, and it will not be separated. Okay, it is in a complex form, it is not in a simple form, so it is unseparable. Okay, this coordination entities, you can see here, you don't imagine that you can separate Ni and CO4. We can't, because it is a complex and it can't be separated. Okay, so NiNH3 6 Cl2. So when it dissociates, you will find that this whole thing, it will be together. That's why it is called as what? Complex ions or coordination entities. So NiNH3 6 it will be Cl is how much? 2. So it will give us what? 2 negatives. That's why here ions will be how much? 2 positive plus 2 Cl negative. Now dear students, now listen very carefully. Here this part is called as what? Coordination entities or complex compound. We call it as complex compound. Okay, this is called as a complex compounds, and the one why it is called as a complex compound coordination entities, because it is not going to dissociate, it's not going to be separated. Okay, it will remain like that only, so that's why it is unseparable, so it is called as complex or coordination entities. And the one which is outside the bracket, they are called as what? Counter ions. Remember these terms, they are called as counter ions. The one which is outside the bracket, it is called as counter ions. The one which is inside, it is called as the complex compounds. And after that they will give us two parts, NiNH3 6. This is called as what? Complex ions, and this is called as the simple ions. Okay, now you can see one is positive, one is negative. Okay, so complex coordination entities are also of three types. We will be, on the basis of charge, we can divide it into three types. That one we are going to discuss now. Okay, I hope you have understood what is coordination entities. Okay, so next one we are going to discuss is types of coordination entities on the basis of charge. So we are going to discuss types of coordination entities on the basis of charge. On the basis of charge coordination entities, we are dividing into three. One is what? Cationic complex. So cationic complex, you can see here very clearly. You can see one example I have given you for coordination entities. Here you can see this part is, this is called as what? Cationic complex. Okay, because it is in a complex form. And this is what? Simple or not? So this one will be called as simple anion, simple anion, and this one will be called as complex cation. Okay, so this is called as what? Complex cation, and this one will be simple anion because it exists alone, and here it is in a combined form, so it is called as a complex. So the first type of coordination entity is cationic complexes. So cationic complexes means those complexes which will have a positive charge on it. We will call it as what? Cationic complexes. Okay, so like for example, this is a cationic complex. Next one is anionic complexes. So when the compounds, when the coordination compound, it will dissociates, okay, it will dissolves, then they will form anion, cations and all. So in that, if the anions are complex, then we call it as what? Anionic complex. So one example it is given, AgCN2 negative, ApCN6 4 negative. So this one is nothing but anionic complexes. Neutral complexes are those in which you will neither have positive charges nor negative charges. Okay, so this CO4, this is a neutral compound. NH3, it is also a neutral. Okay, so these are the examples of what? Neutral complexes. So in today's videos, dear students, what are the thing we have learned it? Let's highlight it. We have learned what is coordination compounds. We have learned the example of coordination compound. Then we have learned a difference between the double salt and the coordination compound. And right now we have learned some important points, some important terms used in coordination compounds. So the first point we have discussed is coordination entities or complex ions. Okay, we have discussed, we have learned the example also. After that we have learned the next point is what? We have learned types of coordination entities. Okay, so let us now move further in the chapter. I hope you have understood. If you are not understanding, I will tell you that you feel free to ask your doubts and try to watch the video again and again so that you will have, okay, up to the three terms we will be discussing, and next lecture when I will be uploading it, in that we will discuss the remaining part, because it has been already too late. It is already by now it is 9:30. So student, I hope you will understand. Okay, so second term we are going to define, or we are going to learn is central atom or ions. It is also called as central metal atom or ions. Okay, so what is that? We are going to learn the atom or ions to which a fixed number of neutral molecules or ions are attached in the coordination entities are called as central metal atom or ions. So the atom or ions to which a neutral molecules, okay, to which a neutral molecules is attached. So this is an atom. To this atom, this is the neutral molecule. CO4 is the neutral molecules or ions which is attached to whom? Ni. So dear students, in these examples, this is a complex or not? Coordination entities. This is a coordination entities. In this coordination entities, you can see that there is one atom to which CO4, that is neutral compound, is attached. So this Ni, it will be called as what? Central atom. Got it or not? This Ni will be called as central atom. Okay. Similarly, another example also we have COCl3 NH3 NH3 three times. So dear students, in this to find out the central metal atom, always remember our central atoms will be in 99% cases it will be metal only. So here metal is what? Cobalt, chlorine and ammonia. So cobalt is attached to Cl3 also, that is negative, and NH3, that is neutral. So this cobalt is attached to a fixed number or not? 3 plus 3 6. Okay, it is attached to the 6 neutral or ions. Okay, neutral or ions are attached to whom? To cobalt. So cobalt will be what? This cobalt will be called as central atom. Got it? I hope you have understood it. Okay. Now next topics, which is very important. Okay, it is asked in your exam also several times. Define ligands. Okay, so what is ligands? Okay, what is ligands? So the neutral molecules or ions bound to the central metal atom in the coordination entities is called as ligands. So let me explain you. See, here you have seen that Ni is what? Ni was called as what? Central atom. Okay, here cobalt was called as what? Central atom. So beside, in this bracket, beside the central metal atom, whatever is left out, that is called as what? Ligands. So in this bracket, okay, in this coordination entities, Ni is what? Metal. So this one will be called as what? Central metal atom. So besides Ni, what is here left out? Here left out is what? CO4 times. So for this CO4 is nothing but a ligands. Okay. Similarly, COCl3NH3 three times. So here CO is cobalt. So this is a central metal atom. So this one will be central atoms, and beside this central atom, whatever is left, that is called as ligands. So here clearly I have mentioned it in the example NiCO4. Okay, so Ni will be what? Central atom. Central atom, because always remember in a coordination entities inside the bracket, besides the metal, whatever things are left out, that is all ligands. So here Ni is central atom, and besides Ni, what is there? CO4. So CO4 will be treated as ligands. So I hope in today's videos you have learned the things properly and you have enjoyed it. Okay, so students, here I will be winding up today's lecture. Okay, in the next lecture we'll be continuing with the remaining part of the chapters. But before I switch off, I will request all of you to, if you find that this making of this video is helpful and you are getting a benefit from it, then dear students, to continue getting the benefit, don't forget to like, share and subscribe my channel Kumar Sir. Okay, if you subscribe and if you share with your friends also will get a chance to learn. Okay, got it? So dear students, hope that all of you have understood and you will do well. You will keep on studying and stay home safely. Thank you.